Mr. Loma here. I thought we would do a quick video on the product rule, and in this case we're going to simplify the product rule so that we can find out when the tangent is horizontal. No one likes doing math just for the sake of showing all the great rules you know. So we're going to actually make this one sort of relevant, and here we go. So first of all, we look at this function and we notice it's a product of two functions. So we're going to have to use the product rule. The product rule is the derivative of the first times the second plus the first times the derivative of the second. So that's what we're going to do. So the derivative of the first is 8 bracket 3x squared minus 8 to the 7. Of course we need the chain rule. That's going to be 6x there. So that's the derivative of the first function. I use f and s sometimes, first and second, times the second function left alone, plus the first function left alone. This middle piece is pretty easy because you just have to repeat the functions times the derivative of the second function. And I joke with my students all the time, make sure that you use the brain cell that you just currently used, put it back in action again. So 9 blah 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 8, and then negative 14 to the x here, so 14x. And that is your first step. So if someone just said do the derivative, you're done. But we're going to simplify this so that we can find out when the tangent's horizontal. So something I've suggested doing is to put together these monomial terms up at the front. 48x, 3x squared minus 8 to the 7, 2 minus 7x squared to the 9. Same here, 14 and 9. Multiply those together. Hopefully you know your 14 times tables. 126x, 3x squared minus 8 to the 8, and 2 minus 7x squared to the 8. One thing you'll notice every time are that these two exponents differ by 1, and those two exponents differ by 1 because of the power rule. It always reduces by 1. Now that we've done this, we can see what's common between these terms. And so we need to determine what's common between a 48 and a 126. And I'm pretty sure you can take out a 6 out of both of those. So we're going to try that. Hopefully that's the largest thing we can take out of both. So let's give it a try, see what happens. We take a 6x out of both. We also have to ask how many of these guys can we take out? These 3x squared minus 8 terms. Well, there's 7 there and there's 8 there, so we'll take out 7. And here we have 8 of those and 9 of those, so we'll take out 8 of them. This thing out in front, I'm going to put square brackets around it. That's your giant common factor. That's what's common to both. And hopefully we've taken out everything we could out of the 6. We'll find out in a second. It's not a big deal if you didn't. 6 times what gives me 48, so that's an 8. And then 3x squared minus 8 to the 7, we've got that, but we need one more of these because we had 8 and we're going to need 9. So we have to put one more in here. The fact that it's a 1 is not surprising. It will always be a 1 because the power rule. Next, 6 goes into 26, 126, 21 times I believe. And we've got 7 of those, but we need 8 of them. So we're going to need one more of those. And coincidentally, it's a 1 again. And we don't need any more of those terms because we had 8 and we need 8, and away we go. Okay, so just a note here. Clever students would notice that we could see there was going to be a 0 here already before we even continue. Same here. You could see zeros coming out of that term. And you can see zeros coming out of this term as well. But the ones that are tricky to find are these ones over here. To find them, we're going to have to expand that and then collect like terms. So you're going to get 16 minus 56x squared minus 63x squared plus 168, I believe that is. And then finally, we're almost done. You get 3x squared to the 7. 2 minus 7x squared to the 8. Would be great if I could just copy and paste. Probably could. 16 plus 168 is 184, I believe. And then 56 and 63 is going to work out to be 119x squared. Beautiful numbers, right? Beautiful numbers. And so now we have it in factored form, which we all know from grade 10, 11, and 12, that factored form is the beautiful form. Tangent horizontal occurs when y prime equals 0. And now that we have it in factored form, we can actually see the zeros fairly easily. Therefore, x equals 0 from the first term. It could also equal plus or minus. Don't forget the plus or minus 8/3 from that bracket. Plus or minus the square root of 2/7 from the second bracket. Yeah, the second bracket. And finally, plus or minus the square root of 184 over 119 from this term that we just created. So this thing actually has 1, 2, 3, 4, 5, 6, 7 places where the tangent is horizontal. And that means it's most likely going to have a min or max point there, but maybe not. It might just be that the tangent was flat and then went back up. So there's your answer. Hopefully that's what you got. And hopefully that video was helpful.